Hello class, today we're going to learn about percent mass. Excuse me, percent mass. If I said, hey, what's your percent mass of you versus your class, I would hope you could understand, we've talked about this before, that you take your mass divided by the class mass. Well, we're going to do that with chemical formulas today. So percent composition of compounds. You can find the percent comp by mass of each element in a compound. So percentage and percent, there's not much difference. I've asked the English department and they can't tell me, besides percentage is more of a noun. So you can find the percent by mass of each element in a compound. We know how to write formulas. From that formula, the formula is telling you the ratio of atoms or ratio of the mass to each one, so we can actually be able to tell that. So here's your equation that you can write on your note card. Percent composition is the molar mass of one element divided by the molar mass of the compound, all times 100. Molar mass of one element divided by molar mass of the compound times 100. Remember that molar mass represents 1 mole of something, which you get that 1 mole from the periodic table because that mass is the molar mass, which is 1 mole. So here's your first and only example. Find the percent composition of copper 1 sulfide. So you're going to want each element of copper 1 sulfide, their mass percent. So first we have to know the formula of copper 1 sulfide. So refreshing your memory, that Roman numeral 1 means that it's a +1 charge. Since it's a metal and a non-metal, we have to make sure their charge is equal to 0, which some of you have been forgetting lately. So sulfur's -2, so it should be copper 2, or excuse me, Cu2S. So here's your equation again. Percent composition is the molar mass of 1 divided by the total molar mass of the compound. So the molar mass of copper 2 sulfide, the whole thing, which we've been doing, is 2 times the mass of copper is 63.55 grams per mole. There's 2 of them, that's why we took it times 2. Plus the mass of sulfur is 32.06 grams per mole. So the total for the compound is 159.15 grams per mole. So all I did is looked at the periodic table and said there's 2 coppers, so I took 2 times 63.55 grams per mole, and 1 sulfur whose mass is 32.06 grams per mole. Adding them up is 159.15. So to figure out for each one, copper, I have 2 of them, so that's 127.1 grams per mole. That was from that 2 times the 63.55. Divided by the total mass was 159.2 grams per mole of copper sulfide. Forgot the 2 there. Gives me 79.85% copper. To find sulfur, I'm going to do the same thing. The mass of sulfur from the periodic table is 32.07 grams per mole. And the total mass, again, of the compound was 159.2 grams per mole of copper sulfide. So taking those numbers, it's 20.15%. Now, most of the time, percent should add up to 100. So if you have 2 different elements here, they should check to be 100. That 79.85 and 20.15 add up to 100. What does it mean to be hydrated? Hydrated means that you have enough water. When you're dehydrated means that you're lacking water. So there are compounds that are called hydrates. Just needed to hydrate myself. Hydrates have some crystals that have water molecules within their structure. So it's a powder system. A lot of the chemicals we've already used, just the copper chloride the other day that we were playing with in lab where we measured the mass, that blue powder was a hydrate. You can't see the water molecules, but the water molecules are stuck. So they're hydrates. So here's a couple of them. Sodium carbonate decahydrate. So we know sodium carbonate's Na2CO3. The decahydrate, deca means 10 waters. Note that that little dot there between sodium carbonate and the 10 waters, that little dot means that it's stuck to. It's not truly bonded like there's 2 NAs, 1 Ca, and 3 oxygens bonded to it. It's not quite like that where it's just kind of stuck there. So it's not chemically bonded, but it's there, and there's 10 different water molecules clumped around each formula unit of sodium carbonate. So I don't know if I really like the word bonded, so I'm going to call it stuck to, because it's very, very, very weak bond. So stuck to it might be a better word. So we could find the mass percent of water in this sodium decahydrate, sodium carbonate decahydrate. So helping you out a little bit, the total molar mass of this is 286.19 grams per mole. Let me explain where that comes from. So I hope you're listening here. To get the molar mass of that hydrate, we already know how to do the molar mass of the sodium carbonate. So you took 2 times 22.99 for sodium, carbon's 12.01 grams per mole, and oxygen is 3 times 16. So you're going to take that, and then you're going to add, that little dot actually means add, the mass of 10 waters. And the mass of water, there's 2 hydrogens, which is 1.01 times 2 is 2.02, plus 16. So 18.02 grams per mole is the mass of 1 water times 10, so 180 added to that. That's where that number comes from. So just a refresher, you take the mass of each compound from the periodic table, and then at the end you add how many water molecules. So you add the mass of 10 water molecules. So this is where I came up with 10 molecules of water is 10 times 18.02 to be 180.2. So to figure out the percent composition of water, I'm going to take the mass of the water divided by the total mass. So I know the mass of water is 180.2. Total mass was 286.19. So I'm going to put that in my equation. So mass of water is 180.2 grams per mole, and the total mass of the calcium carbonate decahydrate was 286.19 grams per mole. Dividing them out and multiplying by 100 comes out to be 62.97% water. 62.97% of the compound sodium carbonate decahydrate has water in it. So 62.9% of that compound is made up of those 10 water molecules that are stuck.